resistor, capacitor, transistor, inductor, diode. Um, so the thing is, make sure that people can always know about what is resistor and types of resistors, unit, and how they use it, applications of resistors, uh, likewise capacitor, diode, and then inductor, transistor. Because the thing is, sensors, all other technologies are evolving with these only. For example, if you take a light sensor, we'll pronounce it as a LDR, light dependent resistor. Again, it is coming under resistor. If you take a IR sensor, for multiple applications, we can use IR sensors. For example, we can use it as a fire sensor. We can use it as a object sensor. We can use it as a black and white sensor. We can use it as a um, heartbeat sensor. We can use it as a eye blink sensor. We can use it for even more multiple applications. Um, so the thing is, it can be used in biomedical engineering, it can be used in electronics engineering, it can be used for electrical engineering, for so many engineering purpose, engineering projects, we are including that. Okay, what kind of thing is that? Is that a sensor? No. The thing is, it has been pronounced as sensor, but the IR transmitter and receiver will come under a photodiode category. So, if you are familiar with what is diode and the working of diode, you
ஐ ஏய் சக்சஸ் மியூட் ஆயிடுச்சு. பரவாயில்ல, இதுவரை சும்மா கட்டி கிடக்கு நியூஸ் எப்படி மியூட் பண்ணிவிட்டு.
So it can be easily said that we can easily conclude that the sensor technology even emerges from the electronic components. So if at all we are not confident in components, we cannot work with. I mean, we cannot produce sensors. We cannot understand sensors, but the saddest truth is we can work with sensors, because the thing is, so many websites are polluting us with pin diagrams, and the thing is, we don't know even the purpose of ICs inside that included inside in that sensor. We don't even know the objective of or the value of the sensor components which has been used in that particular sensor. For example, motion sensor. If you take a PIR sensor, passive infrared, again it comes under photodiode. So this is what we are lagging in, and the thing is, the next part. Okay, I'm starting from. I'm starting from SSI, MSI, LSI, VLSI, and ULSI. So the thing is, if we are very much capable of explaining and analyzing about, if we have capability to analyze about what is transistor, resistor, capacitor, inductor, diode, the next level is we can be going in. Slide I have not changed. I'm just speaking. Okay, so one slide changed. So the thing is, whenever as an industry person, I should go with SSI, MSI, VLSI, LSI, VLSI, ULSI. So the syllabus also should be like that. So in the first semester or first emerging, we are studying about IC 555, op amps 741, LM358, and so many of that. And we are using comparators, differentiators, likewise, and logic gates 74 series as low level. So in the next level, if we take upon medium scale integration, we can automatically go for memory chips, latches, flip flops, encoders, decoders, multiplexer, demultiplexers, likewise so many things, adders, subtractors. There are so many aspects comes under this medium scale integration, and that too which has which is providing a vital role in industrial applications. For example, if you take a memory chip, so we are using memory chips in microcontrollers also and system also. In system, we are using dynamic RAMs as a primary aspect, and in um, embedded systems, in microcontrollers, we are using static RAM as an uh, vital thing. The thing is, whenever you use dynamic RAM, why we are not using it in microcontrollers? So the reason is, whenever you use dynamic RAM, it will be always having refreshment rate. So we should refresh once at 11.625 microseconds to retain the value that could not be possible in microcontroller interfacing. So, but the thing is, SRAM, the question you can ask is why SRAM was not used in system. SRAM will be multiply costed. So if you take 100 rupees for this DRAM, SRAM will cost around 100 rupees. Sorry, 1000 rupees. So 10 times more than the static RAM cost. So we are preferring DRAM for systems because we are using larger spacer, and at least we are using around 8 GB RAMs, 16 GB RAMs nowadays. But in microcontrollers, we are using only KB sizes. So coming upon to large scale integration, in large scale integration we are using microprocessors, microcontrollers. So microprocessors, the thing is, while we are taking interview, if I am asking somebody what is micro, people will simply say that it is a small or tiny part. So the thing is, it is not small or tiny part. It is 10 to the power of minus 6. So the thing is, we could not blame our education system also. We could not blame our educators also. We could not blame our students also. But the thing is, something was missing because nobody is answering like this. So, industry will always expect accurate answer rather than like writing in exams. So the thing, uh, so the thing is, whenever you go for 10 power minus 3 milli, 10 power minus 6 micro, 10 power minus 2 centi. Likewise, if you educate the people with the prefix and uh, the certain values, they will be capable of explaining or understanding so many technologies. For example, nanotechnology is there. If they would not know what is nano, then they could not know the essence of that technology. So nano means 10 to the power of minus. So this is what the thing is. I have a relation to speak about it because IoT is also that kind of thing. People are thinking that Internet of Things is completely different from the electronics or any other thing. But the thing is, it is only a part of embedded system. So I'm coming to large scale integration, microcontrollers. So in microcontrollers, if you if you know the practical aspect, we can interface actuators, we can interface uh, sensors as an input device. We can interface so many communication devices We can interface analog to digital converters. We can interface pulse width modulation. So these kind of things which can be integrated or interfaced with microcontrollers. Okay, fine. So why I am speaking like this? It has a flow. The thing is, okay, I'm starting a project. Um, Suppose I'm going to do a simple home automation project. So I'm taking a controller which is apt for my application. So I'm taking an 8-bit microcontroller. Okay, fine. So don't want to mention about what company it is. Either it may be Area, either it may be PIC, either it may be um, Renesas, either it may be uh, Texas, whatever IC it may be, but it's an 8-bit microcontroller. So I'm going to interface a 8-bit microcontroller with a monitoring device. So always we don't use sensing, the word sensing in industry, we use monitoring. So we'll take a monitoring device input, either one or two sensors for a home automation application. We'll take a template sensors like LDR for light and for veranda street lights and for staircase lights. We'll take PIR motion sensor. Whenever motion occurs, automatically lights should glow. And we'll take gas sensor. I mean LPG gas sensor for uh, LPG leakage system, and we'll take IR sensor or any other door lock sensor for uh, door lock indicators, and we'll take a temperature sensor for automatically switch on or switch off for controlling the speed of the fan. So likewise, if we take these kind of sensors, you should know the practical working fact of the sensor. The thing is, we are supposed to work in the sensor, but without knowing the essence of the sensor. This is the practical thing which we are facing nowadays. For example, if you take a temperature sensor, temperature sensor should be calibrated with respect to 5 volt and the certain formula to convert the analog to digital value to a Celsius value. So that if you think about writing it, then the thing is you can become an expert. But people nowadays, what they are doing is they are going for electrowings or some other website. They are seeing how the calibration has been done, just copying and pasting. Either they understand or not, that doesn't matter. They need only temporary outputs. So the temporary outputs will never grow a technology. So the thing is, and we spoke about a few sensors which can be working as a GPIO sensor. Sorry, digital sensor. So digital sensor. What about sensors then? We are having three types of sensors which is normally used for industries. One is digital sensor, another one is analog sensor, another one is time based, I mean trigger based sensors. For example, if you take an IR sensor, that would be the perfect example. I can say it is a multi usable sensor. How? So you can take a digital sensor for a uh, line follower robot. See, whenever a line follower robot, a piece of IR sensor or a T5000 series, which has an IR transmitter and receiver, which always detects digitally zeros and ones. So if zero white, if one black, or else if zero black, one white, likewise. So the same sensor for a different application. If you go for a little minor changes in a preset value, then it would act as a object sensor for less than 5 centimeters to maximum 7 centimeters. So it won't work more than that. So the thing is, uh, you can have that kind of sensors even like a digital sensor, if you put a comparator LM358 and uh, you can take it as a digital sensor, or else if you have a some kind of resistive resistors, it would work as a analog to digital converter sensor. I mean, for example, if you take an 8-bit microcontroller, a digital sensor will give 0 or 1. In analog, 0 can be represented as 0 and 1 can be represented as 255 in 5-volt DC case. If you give 5-volt DC as an input, then more than 255 will come. So the thing is, sorry, up to 255 will come, 0 to 255. So digital means 0 or 255, analog means 0 to 255. This is the um, major difference what we can go for. Then what else? Again, we can speak about the same IR sensor, which can connected as a biomedical sensor uh, in a heartbeat sensor. In heartbeat sensor, it will generate a pulse. I mean, on off. So, a digital sensor which can be worked with respect to seconds, which is nothing but time-based sensor. For example, our heartbeat can be or will be generated with respect to 60 seconds. So per 60 seconds, what kind of value you get matters. Per 60 seconds, if you get around 65 to 78, then your heart is normal. If it is less than 65 or greater than 78, then that would be abnormal. Likewise, we are supposed to display. So these kind of applications also, the same sensor can be used. And the another example is if you take moisture sensor, due to academic pressure only, there are so many circuits for moisture sensor. A touch sensor, level sensor, moisture sensor, uh, I mean soil moisture sensor, and rainfall detector. Everything has a precise same circuit, but with different body structure. Because in educational institution, people are saying that this has been already done. This has been already done. But the thing is, we have no options to go for any advancement because the 30 sensors will be 31 sensors after 5 years or 32 sensors after 5 years, but these 30 sensors will remain same. We cannot change it as how a resistor value can be derived from BB Roy, Great Britain, very good wife. So the thing is, some things will never get changed. So you have to understand that our electronics is mother of every science branches. I mean, circuit branches, which has all sorts of essence. An electronics person can work at a hospital as a biomedical engineer. Electronics person can manufacture a biomedical equipments, and electronics person can work in aeronautical division as an avionics engineer. Electronics person can work in vehicular automation as an vehicular electronics engineer. Electronics person can work in IT as embedded software engineer. An electronics person can work in Triple as a SCADA engineer, supervisory, control and data acquisition. An electronics engineer can also work as an instrumentation engineer. So we have a lot of responsibilities. We have to, even an electronics engineer can work in civil department also for BACnet, building automation control network. An electronics engineer can work as a robotics engineer, a mechatronics engineer. So without tronics, none of the department is running nowadays. But the saddest truth is we are not realizing that. Even I mean, I'm mentioning staffs and students also. So uh, because an electronic student is migrating for IT because in my point of view, there is no passion of creating electronic syllabus. So we have to look at it, and then uh, we have spoken enough about sensors. So while interfacing sensors, it will create some kind of values. The values will be coming under hexadecimal, and we are converting it to decimal, or we are directly comparing, or whatever it may be. Uh, what the thing these values can be done, uh, how these values can be displayed, or how these values can be compared and controlled by another device. Okay, so we are going to speak about that. So the thing is, I have taken a X value, considering a digital sensor. I am taking a sensor which can be detected, means it should give me a zero. Uh, if it is not detected, it should give one. So the default value is zero. So while the controlling comes under, when zero comes, this thing should be performed. When one comes, this thing should be performed likewise. Okay, what is that? This thing, that thing, this thing, that thing will denote as output devices. Whenever, okay, fine. If you take an object sensor, if you keep it in between door, while the door is closed, then the sensor will get 1. When door is open, the sensor will get 0. So while the door is open, then automatically, if it produces burglar alarm, so we will take it as an intruder alarm project. Likewise, uh, the values can be calibrated and used for different kind of applications. Okay, then we will come to the point again. Okay, I don't have any kind of output devices in existing one. I'm going to keep a wireless device which can be um, which can contain output devices. For example, an X microcontroller is having an IR object sensor, and Y microcontroller is having uh, output device like relay or alarm. So we'll keep it simple. Alarm. X microcontroller is having object sensor. Y microcontroller is having alarm unit. So while X microcontroller object sensor is highlighted, at that time, what I should do is I should enable that Y microcontroller's alarm. How it can be possible? Yes, it is possible. It is possible through communication. So at that time, we are coming inside communication. There are different kind of communication, analog and digital. We are further coming into digital communication. It has serial and parallel. So we are furthermore coming into serial communication. Precisely, we are using asynchronous communication or synchronous communication. Synchronous can be done for short distance communication. Asynchronous can be done for long distance communication. So most of the industries will prefer asynchronous communication. Okay, communication is fixed. Either we are going to do with wired or wireless. So this point of uh, decision making is very, very important, related to application what we are going to go for. So if we are going for a nearby application, we don't need any kind of communication device. Um, so if we go for again less than 10 meters or 20 meters, we should need it will be very much efficient and effective to use a wireless communication device. Okay, how a communication device has been invented. So a communication device, if you take, very simple, it can be divided into two kind of devices. One is IR and another one is RF. So IR data communication, that we would know, as here so many staffs are there. So as we are around that 90s, so many people would know that the particular phone 6600, which Nokia has produced, and 8870. Likewise, so many old Panasonic phones which has one red color spot as a communication uh, medium, which can be communicated with another red color spot in another mobile, so that like our TV remote. So while you keep the both devices in a single line, it can transmit or receive data. If you deviate from that line, it won't. So in that thing, we'll call it as, in technical, we'll call it as line of sight dependent. Line of sight dependent. So uh, to actually, the thing is, this has a lot of disadvantages. See, whenever if you move a little bit aside, left or right, it won't work. The communication might cut because IR works under line of sight dependent. And another disadvantage is, so instead of having 5 centimeters, if you move it to 10 centimeters, it won't work. So only 10 centimeter distance we can transmit or receive data. For that, they introduced RF communication. As everyone know, there are two ways of RF communication. I'm not going to speak anything technical, as you people know technology. You people know everything bookish. I'm speaking like an industry person, which in another perspective, I'm seeing types of these things. So if you take RF, radio frequency, so I'll split it as two types of RF. One is licensed and another one is unlicensed. So if you take licensed, what kind of license? It's like a driving license? Yes. Your phone number is a license. Whenever I call your phone number, precisely that particular phone will ring. So the bandwidth or wavelength I'm splitting for that particular kind of uh, phone is completely different. I'm getting paid for that. So this is what the thing is. For military application, licensed. For intercom applications, licensed. And for so many applications, we are using licensed RF. Okay. Then what is unlicensed? What kind of networks we are using for unlicensed? Simple. For networks, we are using uh, in few applications we are using Wi-Fi also as an unlicensed. Wi-Fi can be used as licensed also, unlicensed also, uh, and especially Bluetooth. For Bluetooth or BLE, you don't have any kind of charges to pay to anyone, for government or private institutions. Just you are going to purchase a device. That's it. So the thing, and Zigbee, Zigbee communication is again non-licensed, which you don't want to pay anything, which can perform, which can communicate around more than 500 meters to 1 kilometer. So we have such kind of unlicensed communication devices also. Coming up onto point. So if I'm going to use for short distance communication for indoor applications, I can use Bluetooth, and it would be better, because the thing is it is unlicensed. So while if you put a router for Wi-Fi, and if an internet is not coming to the device, uh, even if internet is not coming to the device, you can perform with on off or controlling, monitoring or controlling, if you use Bluetooth. If you use Wi-Fi, you cannot, because the thing is, if internet cuts, it won't work. Every technology has its own richness and acuteness and its disadvantages. So, if you are going for more than 100 meters, you can preferably use Zigbee. If you are going more than 1 kilometer, you can preferably use Wi-Fi. So why I'm speaking about it? The thing is, These much time we spoke about embedded systems, and Wi-Fi is a small part which can be interfaced to the embedded system in wireless communication domain. So in embedded system, wireless communication domain, if Wi-Fi is interfaced with a microcontroller, then it is nothing but Internet of Things. So whenever uh, an electronic device can be monitored or controlled via or through internet, it is called Internet of Things. So people, we should know what is Internet of Things, because uh, it's my right to speak in this program, uh, because I'm initiating this. In further programs, so many experts are going to speak more than uh, even more than technical terms. So the thing is, IoT has been emerged. IoT is been a simple part of embedded system. Why I'm why I'm insisting this again and again means, so many institutions are avoiding embedded system, and they are telling they are telling IoT as a greatest technology. That is again a false statement. IoT always is not a technology. Internet of Things is a domain. So technology is embedded system. So the thing is, uh, the practical fact is this, and and the thing we have to understand again, the next one is Internet of Things. Okay, while going for Internet of Things, how an Internet of Things uh, is used in industries or home purpose or any other prototype purpose. The thing is, industry people will never use randomly or commonly, as this is an industrial project, this is a common project like this, because we love technology, always we use it is a prototype, that's it. For a student's project, if anybody is putting some kind of some sort of energy level, the same energy level they will put for industrial projects also, if they are the particular technology lover. uh, so there is no point of telling it as a simple project or an advanced project. An advanced project is a new concept which a candidate is doing uh, newly. I mean, for example, if I did a project with IR sensor, and I'm going for a proximity even more accurate than that. So inductive proximity, capacitive proximity, I have to learn about it. For me, it is advanced, but for my seniors, it is again a simple. So whenever if you are doing something, it will come under research. Whenever if you did something, it will come under okay, already existing. That's it. So the thing is, technology won't change. People, we are changing at every levels. So technology is always remaining same. IR sensor is always IR sensor. Uh, then coming to IoT again. So Internet of Things, how it has been evolving. I already said monitoring or controlling an electronic device via or through internet means again Internet of Things. People saying that it has been emerged now only, but 15 years before itself we did in Ethernet cable, and then by using Wi-Fi, even 7 to 10 years before itself we did using ARM processors. But the thing is, whenever we go for publicity only, we believe that one technology is emerging and booming. It is not like that. If you love technology, you can survive with that. So this is what I just want to say. And IoT, IoT, fine. It has two kind of monitoring and controlling. For example, For a closed infrastructure, we can use internet in LAN, local area network, and we can easily control and monitor a device with respect to local IP address. That can be very much effective when compared to cloud, because cloud needs a lot of internet speed. So if you get high speed internet only, cloud can update. For example, if I am sending data per 2 seconds, either it may be a ThinkSpeak cloud, either it may be AWS, either it may be Blink, either it may be whatever you think, Google Cloud, whatever. But the primary factor is whenever you go for cloud, it needs high speed internet. Unless or until if you don't have internet, you cannot access it. uh, the best thing I can tell you is, see, okay, I'm sending a data to a local host written software website and cloud. So the thing is, I'm sending to a cloud for, uh, I mean, per second. I'm sending a value per second. Per second, each value can be updated in cloud. But the thing is, we are thinking that it can be updated and it will be updated. But the scenario is, if network have server problem or network has bits per second transferring problem, uh, it won't send. Per 5 data or 10 data, only one data will be updated. So I hope few of them would have witnessed this one. So Internet of Things has so many good aspects and has few disadvantages also. Hope in future sessions they'll be giving you so many in-depth aspects in AWS, ThinkSpeak Cloud, or a free cloud, or a local host, uh, 192.168 point something. Why we are using 192.168 point? Because 192.168 point will never come under internet. So we'll always use that local host. So the thing is, if you know the essence of Ethernet cables and Internet protocol networks, then you come to know the value of IP addresses also. Uh, I hope this session would given you some basic aspects of Internet of Things, and I wish to conclude uh, with a with an important point that see, colleges are thinking as if a student works in ESP32 or ESP8266 or STM32 or Raspberry Pi, they would be good in embedded system, and they are uh, ready for industry. That is totally false. Please go and visit a lot of Codicia or some other exhibitions. You come to know Arduino is specially done for school people. It won't enhance any kind of knowledges and skills for engineering college students, uh, and even it will demotivate. The thing is, we people will motivate that ஒண்ணுமே தெரியாததுக்கு வந்து நீ இதை கத்துக்கோடான்னு. ஒண்ணுமே தெரியாததை இதை கத்துக்கலாம், ஃபைன். தேவையில்லாத கத்துக்கிட்டு அவன் எப்படி இண்டஸ்ட்ரிக்கு வேலைக்கு போவான்? So this is what my point is. So kindly 200 ரூபா 300 ரூபாய்க்கு செஷன் பண்றதை கொஞ்சம் கம்மி பண்ணிட்டு பசங்களுக்கு குவாலிட்டியா செஷன் கொடுத்தீங்கன்னா definitely they'll go miles ahead, because I believe as a last bench student எல்லாருக்குமே வந்து uh, they have skills. பட் இன்ஸ்டிடியூஷன்ல இருந்து வெளியே வரும்போது வெறும் பிளேஸ்மெண்ட் மைண்ட் செட்ல அவன் வெளியில வரும்போது அவனால ஒரு ரிஸ்க் கூட எடுக்க முடியல. He is being very much down. He is feeling down. ரிஸ்க் ஃபேக்டர் எடுக்க முடியல. 7 o'clock வரைக்கும் இன்ஸ்டிடியூஷனுக்குள்ள நிறைய இன்ஸ்டிடியூஷனுக்குள்ள வச்சுக்கிறாங்க. அந்த ட்ரைனிங் இந்த ட்ரைனிங்னு. பட் டெஃபினட்டா வந்து அந்த ட்ரைனிங் வந்து அவனுக்கு யூஸ்ஃபுல்லா இல்லை. ஸோ இங்க இது வந்து நான் சொல்லல, ஸ்டூடெண்ட்ஸோட ஃபீட்பேக் தான் நான் நிறைய ஷேர் பண்றேன். பிகாஸ் நிறைய இன்ஸ்டிடியூஷன்ல வந்து ஐம் ஆல்சோ கிவிங் இன்டர்ன்ஷிப்ஸ் ஃபார் பன்னாரி அம்மன், அண்ணா யூனிவர்சிட்டிஸ், கேஎஸ்ஆர் இன்ஜினியரிங். இந்த வருஷமே வந்து கிட்டத்தட்ட ஒரு 7 இன்ஸ்டிடியூஷன் கொடுத்துருக்கேன். பிகாஸ் நான் ஃபேக் சர்டிபிகேட் தரமாட்டேன். எனக்கு வந்து 2 days வந்துட்டு 10 days வரேன்னு சொல்றது பிடிக்காது. அண்ட் ஐ வில் ஆல்வேஸ் ட்ரெயின் கேண்டிடேட்ஸ் இன் ப்ரொஃபஷனல் ட்ரைனிங், ஐ மீன் இன் கமர்ஷியல் போர்ட்ஸ். டெஃபினட்டா வந்து எங்க வீட்டுல so many people don't know what is electronics. அப்ப அந்த ரெஸ்பான்சிபிலிட்டியோட if some other parents would have not known about electronics, I have responsibility to train that candidate and make sure that he will enhance his skill in electronics. So இதுக்காக தான் நான் ட்ரைனிங் யூனிட் வச்சிருக்கேன். மத்தபடி வந்து இன்ஸ்டிடியூஷன்ல பெருசா சம்பாதிக்கிறதுக்கு இந்த மாதிரி இதுக்கெல்லாம் இல்ல. இண்டஸ்ட்ரி சைடு வந்து if you think there are a lot of advancements coming அப்படின்னா, இண்டஸ்ட்ரீஸ்ல வந்து அட்வான்ஸ்மெண்ட்ஸ் வந்து will come with respect to a decade. ஒரு 15 years இல்ல ஒரு 10 yearsக்கோ தான் ஒரு அட்வான்ஸ்மெண்ட் வரும். இன்னுமே வந்து ஐ விட்னஸ் so many companies are using Windows 7, so many industries are using the old versions of controller compilers. அப்போ because that are comfortable for them. So அப்போ we should know about reality. இங்க வந்து 4 வருஷம்ன்றது வந்து ஒரு மிகப்பெரிய டியூரேஷன். இன்னைக்கு நிறைய இன்ஸ்டிடியூஷன்ஸ் வந்து நெக்ஸ்ட் லெவல் போகாம இருக்கிறது காரணம் சீனியர் ஆக்டர்ஸ் வந்து நீங்க நிறைய வந்து என்கரேஜ் பண்றீங்க. ஐ டோன்ட் நோ வை. ஸோ சீனியர் ஆக்டர்ஸ் என்கரேஜ் பண்றதை விட்டுட்டு, அவங்களுக்கு பணம் கொடுக்கறத விட்டுட்டு, நீங்க வந்து அதே பணத்தை வந்து டெக்னிக்கலா வந்து ஒரு பையனை என்ஹான்ஸ் பண்றதுக்கு யூஸ் பண்ணீங்கன்னா இட் வுட் பி குட். ஸோ இது ஒரு பெரிய மெசேஜா இருக்கும். எனக்கு தெரியும் நிறைய கான்ட்ரவர்சி வரும்ட்டு, ஆனா எனக்கு இதை சொல்லணும்னு தோணுச்சு. ஸோ ஐம் வைண்டிங் அப் மை செஷன். உங்களுக்கு வந்து ஏதாவது டவுட்ஸ் இருந்தா டெஃபினட்டா யூ கேன் ஆஸ்க். தேங்க்யூ ஸோ மச் ஃபார் கிவிங் மீ திஸ் சச் அன் வண்டர்ஃபுல் ஆப்பர்ச்சுனிட்டி. ஸோ இதெல்லாம் சீனியர் ஆக்டர்ஸ் வர்றத ஸ்டாஃப்ஸே வந்து ஷேர் பண்ணும்போது, அவங்களே டான்ஸ் ஆடிக்கிட்டு இருக்கும்போது எங்களுக்கு வந்து ரொம்ப வருத்தமா இருக்கு. இன்ஸ்டிடியூஷனுக்குள்ள ஒரு பையனுக்கு எலக்ட்ரானிக்ஸ் கூட டெஃபினிஷன் தெரியல, ஆனா அந்த இன்ஸ்டிடியூஷன்ல பாத்தீங்கன்னா லவர்ஸ் டேக்கு வந்து ஏதாவது ஆக்டரை கூப்பிட்டு அம்மா அப்பாவை அக்னாலேஜ் பண்றேன், பேரண்ட்ஸ் லவ் பண்ணுங்கன்னு சொல்லுவாங்க. ஸோ இதெல்லாம் நமக்கு தேவையில்லாத வேலை. நிறைய வந்து நம்ம எலக்ட்ரானிக்ஸ்ல சொல்லி கொடுக்க வேண்டியது இருக்கு, நிறைய விஷயம் இருக்கு. Thank you one and all for this opportunity. If you have any doubts, definitely you can ask. Doubts இல்லைங்களா? Shall I leave?
Sir, Karthik sir, good morning.
Yes, ma'am.
Hello, sir, Karthik sir.
Yes, ma'am.
Yes, sir, I'm Dr. Veeta, Arulmozhi ma'am, sir, Ratharam Technical Campus.
Yes, ma'am.
Hello, sir. Can you able to hear? Sir, நல்லா இருக்கு sir. Thank you, sir. Nice session. ரொம்ப நல்லா இருக்கு sir. 2 செஷனும் நான் அட்டெண்ட் பண்ணிட்டேன் உங்களுக்கு. சார் இதை வந்து IoT இதை வந்து ஏஐல நம்ம எப்படி வந்து கொலாபரேட் பண்ணலாம் சார்?
Yes, ma'am. Actually, so many people are thinking that AI is a technology, but the reality is yes, AI is not a technology. AI is a component. Every one நம்ம using so many இப்போ Word document, PowerPoint, அந்த மாதிரி வந்து AI is just a component. If suppose okay, how we can access it? அப்ப இப்போ நீங்க வந்து C-ல எக்ஸ்பர்டைஸா இருக்கீங்க, உங்களுக்கு வந்து C ப்ரோக்ராமிங் வந்து இப்போ நல்லாவே எழுத தெரியுது, ஆனா யூ டோன்ட் ஹேவ் டைம் டு ப்ரொடியூஸ் இட். ஒரு 1000 லைன்ஸ் கோட் வந்து உங்களால வந்து இனி எழுதுறதுக்கு வந்து டைம் இல்ல அப்படின்ற பட்சத்துல if you are well and good at that kind of technology, அப்ப நீங்க ஆட்டோமேட்டிக்கலா என்ன செய்வீங்கன்னா, எனக்கு யாராவது வந்து இப்போ ஃபாஸ்டா டைப் பண்ணி தரவங்களோ இல்ல ஃபாஸ்டா ஒரு கோட் ஜெனரேட் பண்ணி தரவங்களோ எனக்கு வந்து இருந்தா நல்லா இருக்கும்னு நீங்க ஃபீல் பண்ணுவீங்க. அந்த மாதிரி ஆஸ்பெக்டுக்கு ஏஐ யூஸ் பண்றாங்க மேம். அண்ட் உங்களுக்கு உங்களுக்கு ஒரு இன்ஃபர்மேஷன் என்னன்னா, ஏஐ வந்து நிறைய வந்து தப்பான ஆன்சர்ஸ் வந்து ப்ரொடியூஸ் பண்ணுதுன்னு சொல்லிட்டு இண்டஸ்ட்ரி பீப்புளே வந்து இப்ப நிறைய வந்து சொல்லியிருக்காங்க. நீங்க அதையும் கொஞ்சம் இந்த மாதிரி ஆர்டிகல்ஸ் எல்லாம் பாத்தீங்கன்னா உங்களுக்கு தெரியும். பிகாஸ் ஏஐ மட்டும் நம்பி லாங்குவேஜ் தெரியாமலோ டெக்னாலஜி தெரியாமலோ இஃப் பீப்புள் ஆர் ரிலையிங் இன் தட், அவங்க வந்து அடுத்த லெவல் போக முடியாது மேம்.
Yes, sir, definitely. Good, sir. Correct, sir. Correct, sir. What you said is correct, sir. I accept it. Yes, sir. Thank you so much, sir. Okay, sir. No, sir. No issues. Thank you so much, sir. Good session, sir. Thank you, sir. Excellent one, sir. Of information, sir.
Sir, எனக்கு ஆக்சுவலா ஒருத்தவங்க கேட்டிருக்காங்க, how to approach you for internships-னு. சார், இன் கூகுள் யூ கேன் சர்ச் எம்பஸ் டெக்னாலஜிஸ் பிரைவேட் லிமிடெட் சார். அது என்னோட நம்பர் தான் சார் இருக்கு. நீங்க ஈஸியாவே அப்ரோச் பண்ணலாம் சார். ஒன்றும் காம்ப்ளிகேட்டடான ஆப்ஷன்ஸ்லாம் இல்லை சார். எனக்கு கேண்டிடேட்ஸ் வந்தா லேர்ன் பண்ற இன்ட்ரெஸ்டோட வரணும் சார், அவ்வளவுதான் சார். வேற எதுவும் பெருசா நான் வந்து எக்ஸ்பெக்ட் பண்ண மாட்டேன் சார். எனி அதர் கொஸ்டின்ஸ்? ஓகே, ஸோ ஆஸ் ஐ நோ, இங்க டெஃபினட்டா வந்து என்னோட சீனியர்ஸ் வந்து நிறைய பேர் இருப்பீங்க. நான் பேசினதுல ஏதாவது தப்பா இருந்ததுன்னா அதை மனசுல வச்சுக்காதீங்க. ஐ ஜஸ்ட் ஸ்போக் வாட் ஐ நோ. உங்களை மாதிரி ஆட்கள்லாம் சொல்லி கொடுத்ததுனாலதான் நான் நிறைய விஷயம் இந்த மாதிரி போல்டா பேச முடியுது. ஐ நோ எஜுகேஷன் வந்து இன்னைக்கு வந்து எல்லாமே வியாபாரம் ஆயிடுச்சு. ஒரு பையனுக்கு நல்லது செய்யறத விட விளம்பரம் பண்ணி சம்பாதிக்கிறவங்க ஜாஸ்தி ஆயிட்டாங்க. அப்போ இதெல்லாம் இப்ப என்ன மாதிரி ஆட்கள் சொல்லல அப்படின்னா வந்து என்ன நெக்ஸ்ட் டைம் கூப்பிடல, அதை பத்தி நான் யோசிக்க மாட்டேன். பட் நான் ஒரு தடவை இதெல்லாம் சொல்றதுக்கு கடமைப்பட்டிருக்கேன். ஸோ ஐ ஜஸ்ட் thank you so much all for providing this opportunity. I'm leaving now.